The aim of this lesson is to give you a very brief introduction to the propagation of VHF radio waves. A signal that travels in a straight line between transmitter and receiver is called the direct wave. In addition, there's normally a signal arriving at the receiver after reflection at the Earth's surface. This is the ground reflected wave. Since both waves follow different paths, they arrive at the receiver with large phase differences. This is further complicated by the change in phase which occurs at the point of reflection of the ground reflected wave. The net result is that an aircraft flying towards the ground station may suffer fading or loss of VHF communications with that station. The range at which this occurs depends on the height of the ground aerial above the surface, the aircraft altitude, and the frequency being used. For VHF-RT, the curvature of the Earth normally gives protection from mutual interference between stations using a common frequency, provided they are well spread geographically. But, as you learnt at the beginning of this course, interference between stations operating on the same or adjacent frequencies does become a problem at higher altitudes. For this reason, a greater number of distinct radio frequencies have had to be brought into operation for aircraft operating in European upper airspace by passing from a frequency spacing of 25 kHz to a spacing of 8.33 kHz. The term attenuation refers to the loss in strength of a radio signal as the range from the transmitter increases. The range of a radio transmission depends on transmitter power. The signal strength received is inversely proportional to the square of the distance from the transmitter. The signal will attenuate as range increases because the radio energy available is spread over a larger area. Radio energy is lost to Earth, the atmosphere, and sometimes to the ionized layers above the Earth. The range of a radio emission depends on transmitter power. The range is proportional to the square root of the power. In other words, if the range is to be double, the transmitter power must be quadrupled. The curvature of the Earth limits the use of the direct wave. The lowest direct wave is just tangential to the surface and is known as the horizon ray. As you can see from the diagram, the aircraft below the horizon cannot use the direct wave for communications. However, contact could be established by either raising the height of the ground aerial or increasing the aircraft's altitude. The formula for calculating the maximum range of direct wave reception is shown on the diagram. From this you can see that the range of VHF communications suffers from line-of-sight limitations caused by the curvature of the Earth, and also high ground or other objects which limit the line of sight. This table shows the division of radio frequencies into the various bands. Note that the VHF and HF bands are used for radio communications. And finally, this table shows the frequencies in the VHF band which are of concern to the pilot.